Hi, I'm Sanketh Bhaskar, co-leader of the Chroma-Glove EOH project, and
I'm the other leader, Athenacia Papoutsis, and here's our project. Now we can introduce the rest of our teammates.
Hello, my name is Ayusha.
Hi, I'm Rory Douglas.
now let's hear from our fifth team member, Joy Hershberger.
Our project strives to use technology in order to make the world more accessible to those who are visually impaired. Utilizing the Chroma-Glove, color is converted into a tactile sensation, and blind users can see the world in full Technicolor. Our final product strives to be easy to use, cost-effective, and reliable. In recent years, technology has gotten smaller and smaller, allowing it to be convenient to wear and easier to use. Numerous technologies on the market also strive to assist visually impaired individuals and allow them to navigate the world more effectively. Vision-assisted smart glasses, such as eSight, can enhance the eyesight of partially blind users. Other wearable devices, such as Maptic, utilize GPS technology to independently guide blind users to their destinations. Other technologies, such as MyEye, utilize camera functions to read text and recognize faces for blind users. However, our approach is less invasive, more affordable, and designed for fully blind users.
The Chroma-Glove is an accessibility tool for visually impaired people. It can be used recreationally, such as to understand your surroundings, or it can be used when color differentiation is an absolute necessity.
The Chroma-Glove is powered by an Arduino Nano Every, which we coded on our laptops and then uploaded the sketch to the board so that with the power source, the glove won't have to be connected to the laptop to actually run. The light sensor in the fingertip of the glove returns a RGB value, which is the intensity of the colors red, green, and blue. With light, the primary colors are actually red, green, and blue, whereas with pigment, it's red, yellow, and blue. In this case, red and green mix to make yellow. So what we first do in our code is determine whether any of the intensities are higher than the other two. So for example, if red is greater than green, and if red is greater than blue, then we'll set red to be true. And we do this for the other two colors as well. Then to make sure if it's a secondary color, we will determine whether the ratio of red to green is within 20%. And if that's true and blue is also false, then we set yellow to be true. And that ratio of 20% we determined by trial and error. That's what most people would call that secondary color instead of just being red or green. And we do this for the other two secondary colors as well. Then once we know what the color is, the Arduino will send a signal to the vibration motors on the back, which will let the person know what color is in front of the light sensor.
Alright, now let's get into some of the hardware of this glove. On the back, we have our color sensor. It's composed of a light to make sure that the color is bright enough when you're facing it the other way, and that's hooked up to the Arduino here, which is then hooked up to the computer. We have our 3 motion sensors here, which are also directly connected to the Arduino, and we have a resistor here to make sure we're not putting out too much voltage. We don't want to blind anyone with this. Right now, when I put this over the red card, you can see that the red motor is vibrating. This motor vibrates for red, this one vibrates for green, and this one vibrates for blue. A combination of these two does yellow, and a combination of these two does purple. We actually don't have a combination for cyan because we realized that most people, when seeing something that would be considered cyan, would see it more as just either a green or a blue, not, very specific shade of turquoise that would be considered cyan. So we decided it was redundant because we couldn't even agree on what the value would be amongst all of us, so we don't have it included.
Our first priority is user satisfaction. So ideally, our first improvement we would make would be to increase the comfortability of the glove and make it more fashionable. Say we sew the wires in, we use a smaller board. Overall, all the electronics would be covered so they can wear it in daily life and not get looks and not get asked questions about it. Another thing we could do to improve the glove would be to add distance sensors on the fingertips. So the users could also sense how far they are from the object they are sensing, and the vibration motors would increase in magnitude the closer they got, and that would allow them to pick up objects better and sense the objects better that they are scanning.
Hope you enjoyed our presentation.